Avogadro's law. This relates volume and moles. What happens if the amount of gas changes? So in this experiment, they measure the volume of a gas. They keep the temperature and the pressure constant, but they vary the number of moles of gas in the sample. So you have some gas, and it's got a volume. And you put more gas in, and you keep the pressure and temperature the same. What do you expect to happen to the volume? It should get bigger, right? You put more gas in, it gets bigger. That's reasonable, and that is what happens. So the volume of the gas in liters is directly proportional to the amount of gas in moles. And this is known as Avogadro's law. Where have we heard that name before? Avogadro's number. And Avogadro's number came out of this concept of numbers of particles being important. So this relationship was formally stated by Amadeo Avogadro. He was born the same year our country was born, 1776. This assumes constant temperature and pressure. So the volume of a gas is directly proportional to the amount of gas in moles. Not the amount of gas in grams or any other unit, but it's proportional to the number of particles. And that's something that's special about gases. So V1 over N1 equals V2 over N2. Avogadro's law. This makes sense. So here's a little boy blowing into a balloon. You put one breath into a balloon, the balloon gets bigger. You put another breath into the balloon gets bigger, right? The more air you put into the balloon, the bigger it gets. That's the relationship. So let's do a problem. A 4.8 liter sample of helium gas contains 0.22 moles of helium. How many additional moles of helium gas must be added to the sample to obtain a volume of 6.4 liters? These questions often get a little bit trickier because we're talking about adding gas. And so we have to be a little bit careful. Well, let's make our table. We've got 1 and 2. Our first number is 4.8 liters. So that's the volume. And it says that that sample of gas contains 0.22 moles of helium. That is N. So lowercase n stands for amount of gas in moles. And then how many additional moles must be added to obtain a volume of 6.4. So 6.4 liters is the final volume. And we have one blank in our table, and we'll call that N2. So then, if you were doing this on an exam, you'd look at the sheet of useful information that I give you. There'd be a whole collection of gas laws, a bunch of equations. Because this one has a V and N only, then you want to choose the equation that has V and N. So that one's going to look like V1 over N1 is equal to V2 over N2. Again, with the annoying fractions, cross multiply. I know some of you can rearrange this equation in your head. That's awesome. You don't need me to explain that to you. I'm doing this for the rest of you. So what am I looking for? I'm looking for N2. So that's right here. I need to divide by this. Divide by V1. So the V1s over there cancel out. If I do it to one side, I have to do the same thing to the other side because it has to stay equal. And divide by V1 over here. N2 equals N1 V2 over V1. Well, N1 is 0.22 moles, and volume 2 is 6.4 liters. and I'm dividing by volume 1, which is 4.8 liters. I look at my units. The units are canceling out, so that's nice. 0.22 times 6.4 divided by 4.8 equals 0.293 repeating moles. If this was a mastering chemistry question and you put 0.293 in for the answer, it would say it's incorrect. Why? Not sig figs. If you put in 0.29, it's also going to say it's incorrect. We need to read the question more carefully. How many additional moles need to be added? Okay, it's not asking for the final number of moles. It's asking how much do you have to add to get the balloon that large. So what we calculated was the final number of moles. We know the initial number of moles. To find the number that need to be added, we subtract. So we're going to subtract our initial number of moles, and that's going to give us 0.073 moles. For sig figs, each of these numbers has two significant figures, and so the 0.293 has two significant figures. 0.22, two significant figures. When I'm subtracting these, I'm looking at where the last significant figure is, and so my answer is only going to have one significant figure. We need to add 0.07 moles of helium to get the balloon or the sample to be 6.4 liters. So that's something to watch out for. Because, I mean, that is kind of a tricky question, and that is the kind of a tricky thing I might do to you on an exam. But I'm warning you about it, so then it's not really a trick, is it? I'm saying watch out for this. Any questions? Let's do another one. A chemical reaction occurring in a cylinder equipped with a movable piston produces 0.58 moles of a gaseous product. If the cylinder contained 0.11 moles of gas before the reaction and had an initial volume of 2.1 liters, what was its volume after the reaction? This one's worse. I'm just pulling these out of the book. I'm not making them up. But if they're in the book, then they're in the test bank, and we have to learn how to do them. Okay, so we got to think about this for a minute. So we've got a chemical reaction. So we've got something going to something else. And it says it makes 0.58 moles of a gaseous product. So we're going to end up with 0.58 moles of product that's a gas. And what's this 0.11 moles? That's the initial volume. That's the volume. See, this is where I personally think that this equation, that this problem is a little bit vague. Because that 0.11 moles, is that the volume of reactants? Did the reactants disappear and become the products? Or is that some unrelated gas? I don't know. So I would not give you this exact question because I think it's bad. It says it has 0.11 moles of gas before the reaction, and it produces 0.58 moles of a product. It doesn't say that this is the reactant and it's disappearing, so we're not going to assume that. So what this means then is we're starting with 0.11 moles of gas, and after the reaction is going to add 0.58 moles. And so our final amount of gas is 0.69 moles. See that? Ones and twos. So the cylinder had 0.1 moles to start with. That's N. And the volume was 2.1 liters. By thinking about it, we've decided that the final amount of moles is 0.69. The reaction added gas to the container. So 0.69. And it's asking us what the final volume is. And that's going to be this, V2. Any questions? That's kind of icky. If you want to get an A in the class, you should be able to do a problem like this. If you're just trying to pass the class, you could blow off a problem like this and you're still going to pass. This is not going to cause you to fail the class. The ones before, the simpler ones that didn't involve adding stuff, you need to be able to do those. So this is V1 over N1 equals V2 over N2. V1 times N2 equals N1 times V2. I'm solving for V2. V2 equals V1 times N2 over N1. So volume 1 was 2.1 liters. N2 is 0.69 moles. And the initial number of moles was 0.11. Moles cancel out. The 2.1 times 0.69 divided by 0.11. 13.17 liters. And that should have two significant figures, so we would give our final answer as 13 liters. Does that make sense? Yeah, if we have something that's generating gas, making more gas in there, then we expect the volume of it to get larger.